Okay, I think I got the screen all up here. Thanks again for the invitation for this. And I do apologize on the front end here. I'm on the back end of the sickness, so bear with me through the coughing a little bit through this presentation. This presentation is going to outline the freezing rain accumulation national analysis. This is a collaborative effort that has been done between WPC, a lot of different National Weather Service people, and the National Severe Storms Lab and the Cooperative Institute here in Norman, Oklahoma. So when we think about freezing rain and verifying how much ice has fallen for an event, the number one gold standard source for verification data out there is the Goodrich icing sensor. I'm sure you guys are all familiar with that. If you're trying to get another more broad picture of where all ice has fallen, you might expand your search a little bit more to local storm reports, or maybe even MPINGs to see where stuff is. This picture on the left here is a mixture of ASOS Goodrich and LSRs. So you can kind of see maybe an estimate of how much ice has fallen for an event looking retrospectively for verification. There's one other avenue that you might look at just to get an idea of where ice has fallen, and that would be to look at the FRAM, or the freezing rain accumulation model, just based off of NWP data. This is available, I know, in a forecast sense on the NBM, Pivotal Weather, many other websites, but again, it's built off of NWP data. And so we're kind of looking to take the science in this project from FRAM and ingest that into MRMS, the multi-radar and multi-sensor suite that's based off of a lot of observations, and be able to merge these two together to create the MRMS gridded ice analysis, which we are referring to as FRANA. So this is going to be a little bit of an overview of FRANA, what we've built, and what we are rolling out this winter season for testing. So FRANA is going to be a new product inside of MRMS. A couple of the input products for it is going to be the HER model analyses of the 0-hour forecast. We ingest the temperature and the wind speed into this product. We'll also be ingesting MRMS's multi-sensor QPE, and then one of the precipitation type algorithms, the spectral bin classifier that runs live in MRMS as well, is going to be feeding into the product. And the last one here is the 1-hour max base reflectivity scans on MRMS. So each of these 4 different products will be in the decision tree that ultimately produces the gridded analysis of ice, or FRANA here. So let's talk a little bit about an overview here and the technical specifications for MRMS. This probably is a review for some of you, but just to make sure everybody's on the same page here. MRMS has a domain over the CONUS. We do have other domains, but this talk is, or this product will just be focused over CONUS. It's on a 1 kilometer horizontal grid. Some of the radar products update every 2 minutes. Other products are updated hourly. So technically speaking, we could produce ice accumulations every 2 minutes, but we're just planning on doing hourly products for right now. In terms of the input data fields inside MRMS, we kind of have 2 different sides of MRMS. One side that focuses more on the radar side of things, and so that's these 2 products. The multi-sensor QPE is an hourly product that's produced primarily based off of the radar reflectivity. But there's other things that feed into it, like the PRISM climatologies, the HER and RAP 1-hour forecast blend. There's an evaporation correction that goes into this QPE, also a rain gauge correction. There's lots of things under the hood, and I can share these slides later. This is the link here to a journal publication that outlines exactly how this QPE works, if you're interested in reading that. Also, we have the base reflectivity 1-hour max. This is, again, another hourly product. And it's just simply the max reflectivity that's been in the base scans across the CONUS from the previous hour. So that's kind of what goes into FRANA on the radar side of things. On the more model-based side of things, we have the spectral bin classifier, which is a precipitation type algorithm. It's a bin microphysics model. that diagnoses the p-type at the surface. It's an hourly product, and again, I have a link here to the paper on the most recent updates and changes to that. And then on the modeling side, in MRMS, we ingest the HER and the RAP analyses. Specifically, the 10-meter wind speed and the 2-meter wet bulb temperature are going to be the input data fields that's being ingested. And just a quick note here, in MRMS, we're always just ingesting whatever is the newest NWP model that's operational. So right now, that's the HER and the RAP. As that changes, if that be the Rufus coming up in the future, then that will replace whatever's currently operational in MRMS. So as those new data streams come online, this product will be updated accordingly with the new modeling systems. So that's all the input fields that are going to be going into Frana. And in terms of MRMS, Frana will be sitting right alongside these products. Again, it'll be an hourly product on the 1 kilometer MRMS grid. And there's going to be 2 main outputs from it. So we'll be outputting flat ice accumulations that are generated from the FRAM, or the freezing rain accumulation model that Brian and Chris Sanders put together. And then we're also outputting radial ice accumulation grids. One little note here is we're also doing something a little bit different, and I'll dive into that on the next slide. We're going to be generating trace ice, and that'll be declared numerically in the grids as 0.001 inches. So let's talk for a second here about ice accumulation math. Just a little refresher for you. So FRAM, the freezing rain accumulation model, here's a link to Brian and Chris's paper back in 2016 if you want to see the full equations. But here's the general logic flow of how it works. So number one, you solve for an ice liquid ratio for each of the variables. So for us, we'll be using the multi-radar, multi-sensor QPE, the HER wet bulb temperature, and the HER 10-meter wind speed. Once we solve for an ice liquid ratio for each of those, then the second step is to calculate a final ILR based off of which weather regime that you're in. So for example here, if you're in near freezing conditions, then you'll weight the wet bulb temperature more than the wind, and then the highest weighted piece will be the precip. If you're in a colder environment, but the winds are higher, you give more weighting to the wind versus the wet bulb. Again, the precip is still the most heavily weighted piece here. And then the last regime here is if you're cold, but you have lower winds, you give lots of weight to the precip rate or the QPE, and then more weight to the wet bulb, less weight to the wind component. The last step here to generate a final ice accumulation is to just take whatever the ice liquid ratio that you found over here and multiply that by the MRMS multi-sensor QPE. Radial ice, again, is just a flat ice times a factor of 0.394. So the only thing that's separate outside of this is how the ice accumulations for these grids will be calculated. But outside of this, for trace ice, this requires a different split off the decision tree. So for trace ice, this is only going to be declared when these 4 conditions are true. And the 4 conditions are, number one, the model 2-meter wet bulb has to be less than 1 degree Celsius. So it's got to be cold. Number two, the precipitation type has to suggest freezing rain or ice pellet or some type of refreezing environment going on. Number three, the multi-sensor QPE has to equal 0. If we have QPE, then we want to generate an ice accumulation over here. But if there's no QPE, then we can look and see if we want to declare trace ice. And then the last condition is if we've had base reflectivity that's had echo within the past hour, then we'll declare trace ice numerically as 0.001 inches of ice in the grids. And this is mainly for the purpose of accumulation. You got to have a scalar in there if you want to accumulate from hour to hour. Excuse me. If you're like me and you need to see how this all works in terms of a decision tree, here's a quick decision tree for you on an MRMS grid point. So you'd start up here at the top. If you're over land, we'd continue on. If not, we're going to mask out anything over the Great Lakes or the ocean. So if we're over land and we're cold enough, the 2-meter wet bulb has to be less than 1. If we're not, it's going to be 0 ice. But if it is cold enough, we'll continue on down the decision tree and look for the precipitation type declaration. If it's freezing rain or ice pellet or a mix thereof, you would continue on. If not, if it's just pure snow or pure rain, we get 0 ice accumulation here. Okay, so if we meet all these checks and we have QPE, this is when we send all the data off to FRAM for this grid point and generate an ice accumulation. If we don't have QPE, that's where we split off here and check the base reflectivity scans to see if we've had echo. If there's no echo and there's no QPE, then we're generating 0 ice accumulations in these locations. But if there's 0 QPE, but we have echo, that's where we'll declare trace ice in this decision tree. So again, I can share these slides. So if you want to reference this, you're welcome to look at this later on. Just a quick view of what the grids can look like. This is an example from February 2021, the cold air outbreak down in Texas. And this doesn't encompass the whole event. This is just a small snapshot of a piece of the event. But this is a 3-hour rolling accumulation. So you can kind of see here how the ice is being declared across the grid. And if you want to know how you can access these grids, we've got 2 ways that we'll be giving these out this winter season. Number 1, we have an experimental web viewer in our in-house at NSSL. And this is being hosted that can only be accessed behind a NOAA.gov IP address. So this is the web link for it here. It's still being worked out, all the kinks on the viewing of it right now. But for most of you, I'm going to guess you'll be accessing this via AWIPS. So we are streaming this via LDM. I know the central region and probably most of the other regions, I think, or some of the other regions are taking it as well. So these grids are being adjusted into AWIPS. And you can look at the bottom of the MRMS menu. I've got a picture here where you can see how you can view each of these different products here this winter season. Last thing that I'll hit here, how can you provide feedback? This is a brand new product. And so we would love to hear your experience with it. We're really looking to see how it works in each individual local CWA. So we really would love to hear from you. If you find something weird, cool, bad, doesn't matter, please let us know. Here's our email addresses for the entire developer team if you want to email us directly, or if you want to just submit some feedback via this form. We have a Google form here. And then last thing that I'll plug is we are doing focus groups at the end of this winter season. So if you've used Frana or looked at it this winter season, we really would love to hear from you in our focus group. So if you're interested, please reach out to Massey. You can email him and we can get you on the list for the focus groups to get an understanding of how it's useful to you and how all of that is going to be worked out. Just listening to the conversation a second ago with Josh talking about freezing drizzle, that's one of the concerns that we have on our end too. Frana is driven on observations, but even detecting freezing drizzle on radar is a challenge. And so we would love to hear your experiences, especially in those types of environments. So I'll stop there for a second and see if we have any questions.
Thanks, Daniel. Todd Foisey asked a question to the group asking if anyone's worked on getting 6-hour Frana into GFE as an observed ice accumulation grid. And so Andy just commented to submit a ticket to the VLab page. Otherwise, I haven't seen any other questions come in. Feel free to raise your hand or drop a question in the chat. All right, not hearing anything right now. Daniel, I'm not sure if you had other information to present or if that was the content of your presentation.
Yeah, that's the majority of it. I guess just the last final thing here before you move on to the next one is just, again, we really would love to hear feedback from you and would love for you to use it in your local CWA because you guys are the ones that are the boots on the ground here and are going to have a much better understanding of how it works than us. So we would appreciate any feedback we can get this winter.
Thanks. Well, yeah, I encourage folks to reach out to Daniel if they have feedback or want to participate in the focus groups. One question before we go on to our next speaker. Does Frana take surface temperature into account?
Yes, it does. Okay, surface temperature. I guess that may be the distinguishing thing. Technically, no, not in the model. The actual surface temperature is not in it. It's the 2-meter temperature that we're pulling out of the HER. So no, that doesn't go directly into it. The main reason why we use 2-meter temperature was because Fram was originally trained off of the ASOS, which primarily has the 2-meter temperature in it. So that's the temperature that's being fed into these grids as well.